Hi, this is the second video in the playlist where we've been looking at the Specimen papers set 1 and it's for the Edexcel higher tier paper. If you follow the link in the description below, you'll be able to download this paper and have a go at these questions for yourself. We finished the previous video at question number 11, so we're going to start with question number 12. I try to encourage you to please stop the video, have a go at the questions and then compare your solutions. Okay, so let's move on then with question number 12, and this one is a fairly typical speed, distance and time type question, and we've got Sean driving from Manchester to Gretna Green. He drives at an average speed of 50 miles an hour for the first 3 hours, then drives 150 miles, blah blah, and so it goes on. Okay, so let's have a look at 1. Now, I've tried to advocate before with other videos is that when you come to these sort of word problems, just do a little bit at a time, read something and have a go at it. So the first part of this, what I'm going to say is I've got speed, which we know is 50 miles an hour, equals distance over time, which we know is 3 hours. So I can work out that the distance is going to be over time, which is going to be 3. So the distance is going to be 150 miles. Okay, so that in this particular case he drives 150 miles for the first part of the journey. Okay, let's look at then 2. Okay, so I'm going to leave that. I'll put 150 miles here. Okay, and then it says he then has 150 miles, so further 150 miles to drive to get to Gretna Green. He drives those 150 miles at an average speed of 30 miles an hour, which must have driven him nuts. But that's a very, very slow speed, I would have thought, to do 150 miles in. But we can use the same formula. So in this is part 2, okay, and we've got speed equals distance over time. Okay, well what we're saying is that the speed was 30, the distance we know is 150, and the time it takes him. Okay, well you need to play around with this a little bit. We can multiply through by t. There isn't space on the video or on this paper, but it basically boils down to that t equals 150 divided by 30, so therefore time equals 5 hours. Okay, so this poor fella now has spent 5 hours driving 150 miles. Okay, so then really to work out the average speed, and he says my average speed from Manchester to Gretna Green was 40 miles an hour. We just need to work with the totals. Okay, so we've got speed again, which we're going to work out, equals distance divided by time. Okay, so the distance that he's driven has been 150 miles to get him to the first 3 hours of his journey. Okay, and then another 150 miles, so he's actually driven a total of 300 miles. Okay, and the time it's taken him has been 5 hours for the second bit and 3 hours for the first bit, which is 8 hours. Okay, so 300 divided by 8, well, again, there's ways of doing this. Okay, the way I would do it is I would do it as a short division. Okay, so I say how many 8s are there in 3? None. In 30, well, there's 3 8s in 30, which is 24, and I've got 6 left over, and that's going to be 7. And I've got 5 left over. No, I've not. I've got 4 left over, so that's going to be 37.5. And again, I'm very aware you might have a different way of doing that calculation, but essentially that's what it should boil down to, is that he is incorrect because he actually drives at 37.5 miles per hour, so he's slightly below what he expected it to be. Okay, hope that's all right. Let's move on then to question number 13. Question number 13 is all about rearranging a formula to make k the subject. And one of the biggest problems with these sorts of things is you've got this awful square root here. So I need to get rid of that square root. So what I'm going to do is square both sides. And if I do that, it means I get m squared on the left-hand side. On the right-hand side, I've got k cubed plus 1 over 4. Okay, I'm then going to multiply, cross multiply by 4 both sides, and I get 4m squared equals k cubed plus 1. Okay, I need to then get k cubed on its own, so I'm going to get rid of this plus 1 by minusing 1. So that's going to give me 4m squared minus 1 equals k cubed. Okay, remember it's k cubed and they want the value of k itself, so if I just cube root both sides, I get k equals the cube root of 4m squared minus 1, and that's the correct answer to this. If you're not sure about rearranging formulas, I suggest you have a look at some of the playlists on the channel, and there's some good examples in there, and that might help you a little bit just to do some extra practice questions. Okay, as there is also on the channel the next question, which deals with solving an algebra fraction. Okay, so this is going to be question number 14. So algebra fractions, again, do crop up. It's well worthwhile getting to grips with how these work. But basically, like adding any other fraction, you need to make sure you've got a common denominator. Now in this particular case, I'm going to make it 6x, okay? So what I'm going to do is I'm going to put both of these under 6x, okay? That's 3 there. Okay, well the first thing is that what do I multiply 3x to get to 6x? I multiply it by 2. So the top is going to become 2x plus 2. Okay, what do I multiply 2x by to get 6x? It's going to be 3. So that's going to be 3 times x minus 2. Okay, and then we just need to expand that out and then simplify it and then work out the value of x. Okay, so if I expand that out, I get 2 times x is 2x plus 4. Remember, 2 times 2 is 4, plus 3x minus 6, and divide that by 6x. I'm going to bring it together now, and that's going to equal to 3. Okay, if I gather up my like terms, I've got 2x plus 3x is 5x, so that's going to be 5x. And then I've got plus 4 minus 6, that's going to be minus 2, again over 6x, and that's going to equal 3. Okay, I'm going to multiply across by 6x, so I'm going to get 5x minus 2 equals 18x. And then really it's just a case of getting x's on one side and numbers on the other. So if I bring that 5x over to this side, by taking it away, I'm going to end up with 13x, if I just put this up here, 13x on that side equals minus 2 on that side. If I divide through then by 13, I get minus 2 over 13 equals x, and that's the answer to this question. Now, I appreciate it doesn't seem particularly a good answer, but actually it is correct, and I think with these sorts of questions now, they are expecting you to recognise that even if it's a pretty awful fraction, it still will be okay provided you've followed all of the steps. Okay, so let's move on then to question 15. Bear in mind this is a higher paper, so some of these questions do get a little bit dense in places, a little bit hard to kind of work through, but essentially, providing you follow all the steps and you do all of your practice, then you should be okay. Things that crop up that can hurt a little bit is this sort of thing here. Okay, so we need to factorise this. Well, what I'm going to do is I'm going to multiply 2 times minus 5. That's going to give me minus 10. Okay, now if I've got minus 10, what it means is, and I need two factors that when I add them together will make minus 3. Okay, well those two factors are going to be minus 5 and plus 2, because if I add minus 5 and plus 2 together, I actually get minus 3. And then it's just a case of writing this with this minus 3x broken into its two factors. You'll see what I mean. I can write this now as 2x squared, and I'm going to write it as plus 2x minus 5x minus 5. Okay, now there's a very specific reason as to why I've done that, and really that's just familiarity with how this works, because if I look at the bottom here, I've got x squared plus 6x plus 5. Well, I can factorise that to x plus 5 times x plus 1. Okay, now with this top bit, I'm going to factorise it again, but what I do recognise is that if I factorise these two terms by 2x, I'm going to get 2x times x plus 1, which is my bottom term here. So I'm kind of betting this is the right way round. And that does take a little bit of practice to kind of get to grips with. Okay, so what I'm going to do, the technique here is I factorise these first two terms. So I'm going to make that 2x, and that's going to be x plus 1. Okay, and then I factorise the second two terms. I'm going to factorise it by minus 5, and I'm going to get x plus 1, because minus 5 times x is minus 5, and minus 5 times plus 1 is going to be minus 5 again. So at the bottom now, I've got x plus 5 and x plus 1. Okay, now I can rewrite this one at the top as 2x minus 5 times x plus 1, and obviously I've got the bottom as x plus 5 times x plus 1. Okay, so it allows me then just to cross out this, and the end result of all of this is I get then 2x minus 5 divided by x plus 5, and that's the answer to this particular question. Okay, quite tough, fair bit of time spent on that to kind of go through and make sure you get it right. Plus you also need just a little bit of experience of when you look at these things to be able to kind of figure out how that's going to work out for you. So please do have a look at some of the playlists on algebra fractions, and that'll give you a bit of practice with these sorts of questions. Okay, let's move on then to question number 16. And question number 16 is one of those questions where you either kind of know it or you don't. There is sort of ways in which you can kind of figure it out for yourself. But to be honest, it's 2 marks. I think, you know, have a go at it by all means. Particularly it's those kind of questions where you can come back to at the end. Basically what they want us to do is to match each graph with a statement in the table. So what they're saying is y is directly proportional to x. Well, that's probably the most straightforward one. Okay, so y is directly proportional to x. What we're basically saying is y is equal to k of x, the constant of proportionality. Okay, and that's actually going to be this one here, which is graph D. Okay, and then we've got y is inversely proportional to x. Okay, well, if y is inversely proportional to x, we've got y equals k over x, and the effect that has is actually this over here. So that's going to be graph number A. And then we've got y is proportional. Sorry about this, I'm running out of space here. So y is proportional to the square of x. So y equals kx squared. Okay, well, again, you kind of either know it or you don't. But if you remember about quadratic equations, then actually it's going to be this one here. Quadratic equations include the x squared term, so actually it's going to be graph number B. Okay, and then finally you've got y is inversely proportional to the square of x. Okay, so y equals k over x squared. Well, again, that's a similar sort of curve relationship. It's a quadratic curve. Okay, and that's going to give you C. Okay, hope that's all right. It's one of those where I think you can kind of come back to it if you want to at some point in the future towards the end of the exam and just have a go at it. Okay, so let's move on then to question number 17. And question 17 deals with proof. proof of congruency. Now, congruency just basically means that two triangles are the same. And what we're actually saying is that this triangle, QTR, is the same as this triangle, which is RSQ. No, it's not. Yes, it is. It's RSQ. Okay. All right. Well, the first thing is that it does actually tell us that S is the midpoint of PQ and T is the midpoint of PR. So what we can say is that QS equals TR. Okay. It tells us that already in the text. And what you will find with some of these questions, if you go back to the text, you'll be able to get a bit of a clue as to where to start. Okay. And then if we look at the diagram, what we're saying is that this triangle and this triangle are the same. We're trying to prove it. Well, actually, QR is the same for both triangles. So QR is same. Okay. Now, if you want to, you can write it as the same base for QTR and SQ. Okay, so that is the same base. So we're proving there two things. We've proved that this is the same length as this length, and we're also proving that this is the same base for both triangles. So we've got two conditions that we've proved. Okay, the final condition that we've proved, or we need to prove, is that if this is the midpoint and this is the midpoint, then it also means that this length and this length must be the same. Okay, so effectively what we've got is something like this, where what we're saying is if this is Q and P and R and this is the same and this is the same, then actually we've got an isosceles triangle. Okay, now if it's an isosceles triangle, not only are the two sides the same, but also the two angles are the same. So PQR is the same as PRQ. Okay, so if those three conditions exist, then what we're doing is we're proving that we have something called side angle side. So side angle side. Okay, so the first proof is that QS equals TR. That's the first proof. Then the second proof will be this angles PQR equals PRQ. And then the final proof is the bottom is that, or the base is that QR is the same for both. Okay, and therefore you've proven that these two triangles are congruent or the same as each other. Okay, so let's move on a little bit to a little bit of calculation, and that's going to be in question number 18. And question number 18, we've got what looks like a very complicated question, and it is actually fairly tricky. There is a little bit of work that you need to do with this sort of question. So I'm probably going to make this the last question on the video. I'm not quite sure yet, but probably the last question on the video. Okay, so let's have a look at this then. So it says the volume of the hemisphere is that, okay, and work out the exact total surface area of the hemisphere. Okay, well, okay, so what we're saying is that if the volume is that, so 250 over 3 pi, the actual volume of our whole sphere is 4/3 pi r cubed. So it's actually a half of 4/3 pi r cubed. Okay, all right, so we've got to be a little bit careful with that one, because actually it's not the whole thing that's giving us the whole volume. It's or rather the volume of this hemisphere is that, but the actual formula is for the whole thing. We've only got half of it, so we've got to be a little bit careful that I multiply this out properly. So I've got half times 4 over 3. Well, that's going to be 1 times 4 over 6, which is going to give me 2/3. Okay, so actually I've got 250 pi over 3 equals 2/3 of pi r cubed. Okay, hope that's all right for you. So now I'm in a position where I can divide through by 3 and get rid of those, or rather multiply through by 3 both sides. And then I've just got 250 pi equals 2 pi r cubed. Okay, so if I just divide through by 2 pi, I get 250 pi divided by 2 pi, and that equals r cubed. Okay, hope that's all right for you. And then I can just simplify that, and I get rid of the pi, and I got 250 over 2, which is 125. So therefore 125 equals r cubed. The cube root of 125 is going to be 5, so 5 equals r. That's great, because then I can use that information to work out the surface area. So what we have done is we've worked out that the radius of this is 5 centimeters, I think, maybe. I don't know. Okay, doesn't really tell us, but 5 units anyway. Okay, so I can use that information now to work out the surface area. So the surface area, well, again, we're given the formula for the surface area of a sphere, which is 4 pi r squared. Now again, don't forget we got a half of it. Okay, so what I'm going to do is I'm going to put in the circle surface area. Again, don't forget you've got a circle at the very top, so I've got to work out the surface area of that. So that's going to be pi r squared, which is our standard formula for the surface area of a circle, and then I'm going to add that to a half of 4 pi r squared. Okay, well, just be really careful, make sure they're quite they usually give you these half spheres actually to play with, so do be careful with these to make sure that you include the half each time. Okay, so if I got pi r squared, and that's plus a half of 4 is 2, so that's 2 pi r squared as well. So this is one lot of pi r squared, and this is 2 lots of pi r squared, so I can combine them together and I get 3 pi r squared. Okay, and then it's a case really of putting in my value of the radius of 5, which is right at the top of the screen there. Okay, so I can write that in as 3 pi 5 squared. Okay, well, 5 squared is going to be 25, so I got 3 pi 25, and 3 times pi times 25 is going to equal to 75 pi, and that's actually the answer to this question. Remember, it says give your answer as a multiple of pi. Okay, well, I got rid of pi this side, but when I put it into working out the surface area, I had to leave it in. Okay, so that came out as 75 pi. I hope that's been okay for you. Let's move on then, I think, to question number 19 for the final question on this particular video. Now, question number 19 is a simplification. Okay, so with this simplification, there's a kind of a technique to do. It's a 3-mark question, so it's kind of worthwhile you working through this sort of question. But basically, we've got this bit at the top here. Now, you might recognise it as the difference of 2 squares actually, but we'll give it a go. We'll just multiply it out, but we've got 6 times 6 is going to be 36, and then 6 times plus root 5 is plus 6 root 5. And then minus root 5 times 6 is minus 6 root 5. And then we've got minus root 5 times plus root 5. Well, that's going to give us minus root 25. Okay. Now, hopefully you can see that this top bit of it is going to cancel out. Okay. And also it means this minus root 25. Well, that's the same as saying minus 5, because the square root of 25 is 5. So I end up with 36 minus 5 at the top, and then root 31 at the bottom. So I'll just write that in. There's root 31. And 36 minus 5 is 31 divided by root 31. Okay, well, I don't want that root 31 at the bottom. I want to try to get rid of it if I can. So what I'm going to do is I'm going to multiply top and bottom by root 31. Okay, so what I end up with is the bottom then becomes the square root of 31 times 31, which is actually just 31. So that's 31 at the bottom, and then at the top I've got 31 times root 31. Okay, so now, even though it looked a little bit awful to begin with, I can just cancel out those 31s and I get the square root of 31 as my answer. Okay, hope that's all right for you. That's 24 minutes into the video. I think we'll... no, we won't. We're going to do this final question because otherwise the next video will be quite long. So we'll do this final question. It's only going to take a couple of minutes. We've got to prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of those two integers. Alrighty. Looks awful when you first read it, but actually it's all right. It's not too bad. Okay, what we're saying is that n equals the first integer, or the first whole number. Okay, so the second whole number is n plus 1 is the second integer. Okay, and then basically it's a matter really of following the text. Okay, the difference between the squares of any two consecutive integers. Okay, well, let's look at the difference. So we've got n plus 1 squared minus n, which is the... So this is the second integer. Take away the first integer is the difference between the squares of the two numbers, okay? And that equals to the sum of these two added together. So it's going to be n plus 1 plus n, okay? All right, now it's a case now of just multiplying this out and kind of working it through so you get the same on both sides. And it actually will work out okay for you. So I've got n plus 1 squared. Well, that's going to be n plus 1 times n plus 1 minus n squared equals n plus 1 plus n. Okay, so let's have a look at that one. I've got n times n is n squared. Plus 1n is plus 2n plus 1, okay, minus n squared equals n plus n is 2n plus 1. Okay, so actually if we look at that now, I've got this n squared and minus n squared, so I can get rid of those, and what I've got is 2n plus 1 equals 2n plus 1. Therefore, it's proven algebraically that it is the same on both sides. Okay, if it's the same on both sides, then it must be true. Okay, I hope that's all right for you. That's 26 minutes into a very long video. I hope it's been successful for you. Please do add comments below in the comments section. I'll always come back to you. Have a look at some of the other videos on the playlist, and we'll crack on with question number 21 in the third video, which is a little bit more challenging. Hope that's all right, and I'll look forward to seeing you very soon. Thanks now. Bye-bye.